Okay, so today we're going to learn how to go from degrees to radians, radians back to degrees. Okay, you got to be able to convert between them. So we know that there's a understanding of pi equals pi radians equals 180 degrees, right? We did that. We proved that. We saw where it came out, right? It showed up on the board. Now, so if you want to convert from degrees to radians, multiply degrees by pi radians and divide, right, by 180. Now, if you think about your Algebra 1 days, your science days, the key to this is knowing who goes on top, who goes on bottom. So if you're going from degrees to radians, degrees are on top and degrees are in the denominator, right? You're going from pi radians to degrees, then pi's on top in the main problem, and then your conversion, pi radians would be down in the denominator, right? They have to cancel out the units, correct? Now, basically, pi radians equals 180 degrees is really the only information you need to kind of get in your brain. Pi radians is 180 degrees. Boom. No doubt, right? So, you ready? Y'all good? Huh? Now, let's look at these. I want you to, we talked about these, but, well, the degrees, and we talked a little bit about radians, right? So I want you to kind of understand. Do you have to draw all these? No. Here's what I would do. I would say pi over 6 is what? Equal to what? 30 degrees. Pi over 4, boom, 45 degrees. So I'd like to, here equals that, this and equals that. I'd have all these down. And here's why. You put those to memory, you just made your life a lot easier. Okay? Pi over 3 is 60, pi over 2 is 90, pi is 180, 2 pi is 360. I'd also put 3 pi over 2 being what? 270, right? That's one that they left out. I would have done that. Now, you don't have to draw the circles. You just go boom equals, boom equals, right? Yeah, that's a mathematical technical term for writing it down. Boom equals. Okay. How do you remember on pi over 6 and pi over 3 whether they're 60 or 30s? The denominator is always opposite. If it's pi over 6, it's 30. If it's pi over 3, it's 60. Okay? So if you are yes, I'm trying to grab something that's not going to. Okay, let's do this. 2/3 pi. 2/3 pi is 2 1/3, right? Which would be how many degrees? 120, right? If you think in terms of that and do those fractions, then life will also become much easier. So the more time that you put on something like this, the better it's going to be. Yeah? All right, has everybody got this? Yes? No? Who's still copying? I need you to take these 3 problems. I need you to take these 3 problems, and I need you to convert. Well, let's do the first one together, and then I'll let you do the other 2. Fair enough? We're going to convert from degrees to radians. Yeah? So 135 degrees times what? Pi over what? 180. Now, these are radians here. That's the unit, right? So basically, what's 135 over 180? Okay, put it as a fraction. Can you do it? So that would be 3 pi over what? 4. How? 135 divided by 180. You press the 135, hit the division, type in 180, hit enter. Who has to cancel? See this? Those units have to cancel. So if I'm going from degrees to radians, degrees has to be in the bottom. Yes, ma'am. Pi and 180, they're the same. One's in degrees, one's in radians, right? Always put it, listen guys, if it can be put as a fraction, put it as a fraction. Okay, you can hit the little N over D button on your calculator, the little fraction button. You can type 135 in the numerator, 180 in the denominator, hit enter. It will simplify it for you if it can be, right? If it goes straight to a decimal, hit the button above it, the little text wave sign, the approximation button. It will convert it. All right? I need you to do B and C. B and C. Go. Okay, guys, listen. Does it matter if it's positive or negative? Yes or no? Yes, only in the case that the sign goes at the very end, right? This negative 270, I'm still going to convert 270, right? It's just going to be what? Negative 3 pi over 2, right? Radians. Did you put radians? Need to put radians. Remember when you use degree sign, you need to put that little degree thing up there? You need to tell it's units, because if it doesn't have units, are we talking 270 radians or are we talking 270 degrees? You need to understand who you're talking about, right? The details matter. So how did you do? Did you get 3 pi radians? Did you get negative 3 pi over 2? Yes? Any questions on that? Do you see how they're marking out degree, degree? Y'all see that? Those have to cancel. So if you set it up that way, you've got conversion. 180 pi, and then just make it go, right? Questions? Anybody? If you can go from degrees to radians, you can go from radians to what? Okay, so I'm going to give you 3 more, and then we'll be done. I'll take questions off of your homework last night. Fair enough? Yeah? All right, y'all good with this? Okay. Convert these from radians to, go. Give you the 3 problems. Let's see what you can do. Let's see what you can do. Okay? Let's see how you did. Did you go, the pi's do what? What do the pi's do? The pi's actually cancel out too, right? So that's really negative 1 times 80 divided by what? 2. They left out this, right? 9 times 180 divided by 2, right? Yeah, they're wrong here. They got a typo. That should be that. Oh, yeah, okay. All right, I see what they're saying. The conversion. Hello? Let's look at C, because I want to point out one thing here. Do you see that I'm marking out pi's on the others? This is just 2 radians. All right. So guess who has to be there? Pi. So really, that's 360 divided by pi, right? Can you put it as a fraction? Yes or no? All right, wait. We wouldn't put these as fractions. So could you put that as a fraction? I'm just curious. Probably not, because it's an irrational number, right? How you do that? 360 divided by pi, right? Hit enter. And then you hit the little button above it, right? And you get 114.59 degrees. If you get a decimal, convert it back to degrees, go to 2 decimals. That's standard. Hey. So you go, what if I get a decimal? You don't ask me how many. 2 decimal places. We'll standardize on everything. 2 decimal places. Okay? Yeah? Okay, good. All right, Sam? Did you forget to do this?
Yeah, I didn't do it yet. Yeah.
Radians, they have to cancel, right?
Yeah.
The pi, they didn't have a pi up here, did they? If you will set it out systematically like that, guys, there's no way you can make a mistake. You do something other than that, guess what? You're going to make a mistake. Okay? Y'all good? Any other questions off degrees, radians, radians to degrees?
Yes.
Ladies, any other questions? Yes.
I don't understand what
This is a conversion. That's a conversion right there. That's like a rubber stamp. Boom. Radians on top, that's going to happen because radians on the bottom, right? It's like, how would you convert feet to inches? Huh? Look, it's so, let's say, huh? All right, but so I said 3 feet. Feet has to come down here. So feet cancels, right? Yeah, this is a conversion, right?
So you're just trying to get it.
That's it.
Okay.
And you just multiply across. That shows you that you have it set up correct. And you just top, bottom, and then you simplify it at the end, right? That's it. That's all you do. Yeah. Yeah. If you don't write these down, you're not gonna be. You try to do it in your head, and you're not gonna see it. All right. Any questions? So you got 3 examples that show going from degrees to radians, and you got 3 going from radians to degrees. Now, how can we use this to help us? Hey, how can we do this to help us to get things such as reference angles, which are hard, on radians? So let's show you. Hey, there's a lot of chit-chat going on that needs to stop. Okay? So we'll ask nicely. Okay, so reference angles, right? 17. You want this one? Let's go here, and I want to show you something. Because one of my students in 6th period said, hey, Palmer, I do it this way. I said, well, that's great. I want you to be able to do it both ways. Okay. Reference angle. 17 pi over 2. Oh, snap. We're looking at what radian is from that angle back down to the x-axis, right? Guys, what if I told you 17 pi over 12 times 180 over what? What would this 17 pi over 12 be as degrees? Let's just, how much? You sure, 75? No, let's do it. 17 times 180 divided by 12. Guys, 255 degrees. Okay, can you do the reference angle on that now? Do you see how that can help you? Okay, so we go here. It's a positive angle, so we've got to go which way? That's 255, let's see. That's less than 360. So it's 360, 270, 180, and 90 are my references, right? Those are my quadrant angles. Yes? 0, 90, 180, 270, right? 360? So it's less than 360, so I can't do that, right? 270, it's a little less than 270, right? But it's more than 180. So I know that I'm going to be somewhere in here, right? Y'all agree? So, if I had to draw that, that's where it would be. Where would the reference angle be? The reference angle would be right here, right? What would that be? What's minus 180? Hold up. 255 minus 180. 75. 75 degrees. Can you convert that back to radians? 75 times what? Yeah. And then that would be what needs to go there. Does that help you a little bit? Then it makes it a little bit easier to discuss we have.
So you don't have to enter the number, and then you have to draw it, and then you have to do that.
That's one way. I think you would probably be better doing it this way since you've had much more practice on that, right? I know you got papers on a notebook. Okay?
When are we gonna do 7